Welcome to Processing Chessboard Calibrations, part of the Theia 3D tutorial series. In this video, we will describe how to use the Chessboard Calibration tool within Theia 3D to process extrinsic chessboard calibration trials. To start, your video data should be organized in the nested data structure required by Theia 3D. If your video data is not yet organized, you should watch the Organize Videos tutorial and complete that step before proceeding. If you are using OptiTrack Prime Color cameras, you should have a lens calibration.txt file. If you do not have a lens calibration file, you should watch the Processing Lens Calibrations video and complete that step before proceeding. First, navigate to Calibrate Chessboard under the Calibration drop-down menu. Next, click Load Videos, then navigate to and select the folder containing the Chessboard Calibration trial. If the videos need enhancement to increase the brightness, contrast, or correct the white balance to improve visibility of the blue squares, you can watch the Video Enhancement Tool video and use the Enhancement tool. It is important that the blue squares are properly detected throughout the calibration trial and in the desired origin frame of the trial. Next, select the desired frame grab step value. This value determines the intervals between video frames that are used for calibration. Selecting one will result in every video frame being used, 2 results in every other video frame, and so on. Using smaller frame grab step values will increase the time required to process the chessboard calibration trial, but may result in improved calibration metrics. If your chessboard calibration trial was collected at the recommended 20 frames per second, a frame grab step of 5 is a good starting point. The next step is to load the camera lens intrinsic parameters. If you are using Sony RX02 cameras, the Use Default RX02 intrinsic option should be selected automatically. If you are using OptiTrack or other cameras that require the use of custom intrinsic parameters, click the Load Intrinsics button, then navigate to and select your saved intrinsics.txt file and click Open. If there is an error when loading the lens calibration file, check that the camera IDs are consistent between your lens calibration file and your chessboard calibration trial. Then, select the origin frame that should be used to establish the global coordinate system origin. The chessboard is generally required to be clearly visible in at least 3 camera views during the selected frame. But if it is only visible in 2 cameras, the Min 2 Cams for Origin Triangulation button can be selected. The blue squares are required to be detected in this video frame, which you can check using the Video Enhancement tool Blue Mask. If you need to modify the orientation of the global coordinate system relative to the chessboard surface, use the normal and long axis options to make this modification. Theia requires that the global z-axis is directed vertically upwards, but the x and y axes orientations can vary. Finally, click Calibrate Cameras. Once the calibration has finished processing, a dialog window will appear indicating the outcome of the calibration, including some calibration metrics. Check that a similar number of frames were used to calibrate all cameras, and that the desired origin frame, or a close frame, was used for the origin triangulation frame. The main quality metric of interest is the RMSE diagonal value. Generally, a value of 1 mm or less is considered an excellent calibration, and a value of 2 mm or less is considered acceptable. Detailed descriptions of the other metrics are available in our online documentation. After reviewing the results dialog, use the Save and Assign, or OK buttons to proceed. The Save and Assign option will allow you to save the calibration file and immediately assign it to any corresponding movement trials. The global coordinate system will now be visible within every camera view. If it is not positioned where the chessboard was located during the selected origin frame, this indicates that the chessboard is not visible in enough camera views during the selected frame, and the closest previous frame in which the chessboard was visible was selected. This issue typically occurs when the cameras are positioned low and parallel to the ground, or if there is lighting glare reflecting off the surface of the chessboard. It can be useful to place marks on the ground or align the chessboard with existing marks during the localization portion of the calibration trial, which can be used at this stage to confirm that the global coordinate system is positioned and oriented as expected. If your origin is not set as desired, you should watch the Adjusting Reference Frames video for approaches to set it as desired. You may also want to review the calibration videos for visual feedback on the calibration trial. Throughout the trial, zigzag patterns will appear on the board. A green pattern indicates that the chessboard was detected in 3 or more views and so the current frame was used. Yellow indicates detection in fewer than 3 views and so the current frame could not be used. Red indicates poor reprojection of the 3D pattern and so the current frame was excluded. And gray indicates insufficient visibility of the blue squares and so the current frame could not be used. This visual feedback can be used to influence your calibration procedure, in order to maximize the frames in which green patterns appear throughout the recording. The most common reason you may encounter a failure when processing a chessboard calibration include The camera IDs do not match those in the intrinsic lens calibration TXT file. The intrinsic lens parameters are incorrect or insufficient. The chessboard was not visible in enough overlapping camera views during the calibration. The chessboard did not remain flat during the calibration. Thank you for watching this Theia 3D tutorial on processing chessboard calibrations. If you have any questions that have not been answered, please feel free to reach out to support@theiamarkerless.com.